Here is the response to the question number 11. This is a difficult question. I will try to explain to you in the easiest possible way. The question is asking you to find the area which is confined by these three circles. This is the little white unshaded area. That one we have to find. How we are going to find the area? It is given that the circle, each circle has a radius of 1 with radius 1, and these three circles are tangent to each other. So to find the answer, what I am going to use a diagram which might help you to see the explanation. I'm going to connect these all the three centers, and you just watch. This is what I'm going to do it. This line is connecting the three centers, and then it creates a triangle which is moved here. So now in order to find the area, I have to find the area of this triangle, which is an equilateral triangle. Why? Because it has each side is the diameter of the circle. This is radius and this is radius, so the whole thing is a diameter from here to here. So the radius is 1, so the diameter or the each side of this equilateral triangle is going to be 2 as shown here. So first I will find the area of this triangle, and then I will find the combined area of the three sectors. This sector, this sector, and this sector, and I will take away from the area of this equilateral triangle. So let us first find the area of the equilateral triangle. As you can see, this side, the distance between the center to center is 2. And if you want, you can see that this is the triangle which I pulled it out from here. So it is exactly the same triangle which I pulled it out, and it is here. So this side is 2, this is 2, this is 2. This point is being the midpoint. This side, this portion, half of this side is 1. So I can see that, and this triangle, this little triangle within the triangle is a right triangle, and it is 30, 60, 90 degree, because this angle is 60 degree being the equilateral triangle, and this is the altitude which is dividing this angle into 30 and 30. So this is 30. So obviously this is 30, 60, 90 degree triangle, and if one leg of this special right triangle is 1 and the hypotenuse is 2, then this other leg, which is also the height of this equilateral triangle, is going to be square root 3, because 30, 60, 90 degree special triangle has 1 square root 3 and 2, the ratio of the sides. So now it becomes easy for me to find the area of this triangle. So the area of the triangle is going to be, area of this equilateral triangle is going to be equal to half, and the base is 2 because each side is 2, so half times 2 times the height which we found it is square root 3, and this 2 divided by 2 gives me 1. So the area of the triangle, the equilateral triangle, is square root 3. Even having this much information, the area of this equilateral triangle is 3. We can check all the given choices that none of the choices other than D is showing something has been taken out from square root 3. Square root 3 minus pi over 2. Pi over 2 should be the area of these three sectors together. But anyway, that part we will discuss. So now after getting this much information, we can try to have my educated guess that the answer should be D, which is square root 3 minus pi over 2. But how come is this? I'm going to find out. So the next part comes to find the area of these three sectors. Each sector has a center angle which is 60 degrees, 60 and 60 degree. If I put either I have to find the area of each sector individually and then add them up to find the total area of these three sectors, or I should try another visual way. And I can see that these three sectors, if I put them next to each other, because they have 60-degree angle, then they should form a 180 degree, which should be a semicircle. I'm going to visually demonstrate to you that yes, it makes a semicircle. So now we know that the area of this triangle is square root 3, and I know that the answer is going to be D, but still I'm trying to figure it out. How come the area is pi over 2? So watch these three sectors. As I said, I'm going to align them next to each other. When these three sectors, I move them and place them next to each other, they exactly form a semicircle, and that is what I mean, that if I put them together, then this will form a semicircle, these three sectors. How they are making the semicircle? Because this angle is 60, this vertex angle is 60, this one is 60, so 60 plus 60 plus 60 makes 180, and that is how this is making a semicircle. Now it is easy to find the area of the semicircle whose radius is given as 1. So the area of the whole circle, the entire circle, is going to be pi r square. R is 1, so the area is going to be pi, but we are only considering the semicircle, so the area of these three sectors should be half pi. So now it is true that the answer is D. So the area is going to be square root 3 take away pi over 2. In this question, the important part is that if you can visually see that this is going to be a semicircle, these three sectors forms a semicircle. I hope you understand these steps and the visual approach to see the question, how this question is answered. I'm also going to show you the written statement, so that if you want to read the written statement, you can read it later by watching the video again and again. So my written answer is this, which you can read it. The equilateral triangle, the area is the square root 3, and the three sectors together make a semicircle, so the area is pi over 2.